We are continuing to look at trig graphs. We looked at the basic trig graphs of the sine and cosine functions. And let me just go ahead and do a quick sketch of the sine function, because I want to go ahead and describe some of the features of a graph that we'll need to understand. So once again, the basic sine function, the x is the angle in radians, and the y is the value of the sine function. We know it goes from 1 to -1, and the period, or when the graph starts repeating, is from 0 to 2 pi. So here's the label for our x-axis. And basically, when you do a sketch of these trig graphs, sine or cosine, normally we just do the main points, what I call the key points, pi over 2, pi, 3 pi over 2, 2 pi. Because we know the sine, for instance, when the angle is 0, we know that the sine is 0. When the angle is pi over 2, we know it's 1. When the angle's pi, we know we're back to 0. 3 pi over 2, we're at -1. And at 2 pi, we're back to 0. So with those points, we can make a rough sketch of what we call the sine wave, or the sine graph. Now let's talk about 3 aspects of this graph that are going to become important. The first one is what we call the amplitude. The amplitude you could think of as how high and low the graph goes. So in this case, the x-axis, this x-axis is like the middle of the graph. When I go to the highest point of the graph, from the middle of the graph, that's called the amplitude. In the same way, if I go to the lowest point of the graph, those are both considered the amplitude. And the amplitude is always a positive number. We don't have a negative amplitude. Even for this one, we say the amplitude for this graph is 1. From the middle of the graph, the highest it goes is to 1. Over here, from the middle of the graph, the lowest it goes is -1. We say this graph has an amplitude of 1. The second part of the graph, which we like to talk about, is called the period. The idea of the period is how far, we're looking at the x-axis, how far on the x-axis until the graph repeats. That distance is called the period. So normally what you do is, for instance, on this graph, I go to a point where my value is 0 here, right? I'm sitting here at my y value 0, and I'm going to follow the graph I don't just go to 0, because you notice here at this 0, I'm going up. I'm moving in a positive, sort of a positive slope. I'm moving up like this. Here I'm moving down. So I keep going, and instead, once I get to here, that's when it starts repeating. So if I start here, once I get to here, if I kept drawing this graph, then it would start repeating. So I say from here to here, this distance, hope it's not too messy, is called the period. It's how far the graph goes until it starts repeating itself. And in this case, I start here at 0, I go to 2 pi, we say the period of this graph is 2 pi. Now there's one last aspect to these trig graphs which we are going to talk about and need to understand. Let me redraw my graph since it's getting sort of messy. And this third one sometimes can be the most confusing. So here I'm going to graph once again y equals sine of x. Here's x. So once again, 2 pi, halfway between pi, halfway between that is pi over 2, 3 pi over 2. Once again, for the sine, when the angle is 0, the sine is 0, goes up to 1 at pi over 2, back to 0, down to -1, back to 0. So there's a sine wave. Now this third one is called phase shift. And the phase shift is how far the graph moves left or right. In other words, I brought a red pen to see. It's almost like you take this whole graph and you shift it to the left or to the right. Let me just shift this whole, how about I shift this whole graph to the left? And I'm going to move every point. Right here is pi over 4. I'm going to move every point on this graph pi over 4 to the right. So this point goes here. This one now moves over here. This point now moves over here. The bottom of the graph now moves here. And this point would now go here. Now if I connect all the red points, what you're going to see is it's like that whole graph has just been moved to the right by, in this case, pi over 4. Now this phase shift can be tricky because sometimes you have to figure out whether it's a positive or negative. For now, I'm not going to worry about that. I just want you to understand the concept of a phase shift. The phase shift means the graph moves from left to right. So really there are three main aspects that we're going to look at now with these trig graphs. We're going to look at amplitude, period, and phase shift. And what we're going to do is, we're going to do two things. First of all, we're going to start looking at some equations for trig graphs and see how to determine the amplitude, the phase shift, and the period. And then later on, probably in the next video, we are going to look at some graphs and from the graph try and derive the equation. So that may not all quite make sense right now, but let's forge ahead. So there are really two kinds of graphs we're going to look at: sine graphs and cosine. And here are the what I'll call the general equations. We'll do the sine first. A times sine, in parentheses, bx plus c. And then for the cosine, it's exactly the same, except instead of the sine function, we have the cosine. Now the a, the b, and the c are going to be numbers in an equation. And let me define what a, b, and c are, and then we'll do some examples, and then it'll all make sense. When we're given an equation and we can figure out what the number a is, the absolute value of a is the amplitude. Right? And we just did this graph a minute ago where we said the amplitude is the distance from the middle of the graph to the top of the graph, or the middle of the graph to the lowest point of the graph, right? That's amplitude. So we have a way, in a minute, we're going to look at some equations of graphs, and we're going to be able to determine what the amplitude should be. The second thing we looked at is the period. Remember, the period is how far along the x-axis it takes for the graph to start repeating itself. We can actually calculate the period, and in this case it's 2 pi divided by the absolute value of b. So it's 2 pi over b. So whatever number is in front of the x inside the cosine or inside the sine, if we take 2 pi, divide it by that number, that's going to be the period. Once again, what was the period? Remember, the period is how far it takes for the graph to start repeating itself. And then the third thing we talked about was the phase shift. Now the phase shift is where it starts to get a little tricky. But we have an equation for the phase shift, and we can calculate the phase shift by negative c over b. And once again, the phase shift is how much the graph shifts to the left or to the right. So the bottom line is the three parts of the graph that we discussed, the amplitude, the period, and the phase shift, we can actually take an equation of a trig function and calculate the amplitude, period, and phase shift by figuring out A, B, and C. So let's start out with some fairly straightforward examples. Matter of fact, just to keep it really simple, here's a trig function. And I want to figure out the three things. I want to know the amplitude of this graph, the period, and the phase shift. In other words, if I was to go graph y equals sine x, what would the amplitude, the period, and the phase shift be? And what you have to do is, it's almost like steps. You have to determine A, B, and C. You have to look at the equation you're given and figure out numbers for A, B, and C. And we'll do that in just a second. Normally, second thing you do, which is usually the easiest, you can find the amplitude. The next easiest is to calculate or find the period. Now normally what I do, and I'm going to show you, is after I find the amplitude and period, I sketch the graph of what I know so far. Now if there is a phase shift, then number 5, you find the phase shift, and then the last step is you're going to now adjust your graph to include the phase shift. So I'll just say adjust graph. And this will make sense in a minute. So let's look at this example. Somehow I have to see how does this equation compare to y equals a times sine of bx plus c. Well, hopefully you can see a is whatever is in front of the sine x. In this case, a must be 1. Now the b and the c are the stuff inside the sine. Just to make this very clear, I could have written this sine of x plus 0, right? Hopefully you can see b is whatever is in front of the x inside the sine. In this case, b is 1, and you can see that c is actually 0. So now that I know a, b, and c, I can figure out my amplitude and period. So the amplitude, we said above, is simply the absolute value of a. So it's going to be 1. So in a minute, I'm going to make a rough sketch of my graph, and I know the graph is going to go from -1 to 1, right? Because it goes from the middle of the graph up to 1, and from the middle of the graph down to -1. Now the period, it's this equation, 2 pi over absolute value of b. So 2 pi. Now the b here is 1. So the period is 2 pi. In other words, the whole graph is going to go for 2 pi before it starts repeating. Now I'm not going to calculate my phase shift. I'm going to go ahead and, based upon the amplitude and the period, try and sketch a graph. Now here's the thing I like to do. As soon as I find a period, I do this thing called, it's what I call the key points. And these key points just gives me a quick way to help me sketch the graph. So what you do is you take the period, or how about I call key point spacing is probably a better word. I take the period and divide it by 4. So 2 pi over 4 ends up being pi over 2. Because what that tells me is when I go sketch my graph, normally when I look at this graph, the thing that makes it easy to graph is I like to figure out this point where it's 0. I like to go to the highest point, the maximum, and then back to 0, and then to the lowest point, and back to 0. I call these my sort of like my key points. If I can figure out where those are, I can make a rough sketch of the graph. Well, what this is saying is the key points are going to occur every pi over 2. So now, based upon all this information, I'm going to make a rough sketch of this graph. So here's my x-axis. Here's my y-axis. Since I know the amplitude is 1, I'm going to, on my y-axis, mark off -1 and 1. Because I know the graph is going to go from -1 to 1. Now in terms of the x-axis, first of all, I know the period's 2 pi. So I go out here and put in my 2 pi, since I know after that the graph just repeats. And now here's where this key point helps out, because I'm now going to basically cut this 2 pi in half, and then I cut it in half again. And you notice what I've done here is, if my key point spacing is pi over 2, look here. Pi over 2, pi over 2 more, pi over 2, pi over 2. And what happens is, since I know this is a graph of y equals sine x, I know it starts at 0. My first key point, it's going to be my maximum. Then it goes back to 0. At my next key point, it goes to -1. The next key point, back up to 0. And then it starts repeating. And then I can sketch the graph. There's the graph of y equals sine x. All right, that was pretty simple. But let's do some more where actually the amplitude and the period and the phase shift might change a little bit. All right, how about, here's an equation, y equals 2 cosine x. So I'm going to take this equation, figure out the amplitude, the period, the phase shift, and then try and graph it. Well, once again, based upon my general equation, hopefully you see pretty easily A is going to be 2, B is 1, and C is 0 again. So the amplitude, which is A, is going to be 2. The period, which is 2 pi over B, is going to be 2 pi. And my key points, if I divide 2 pi by 4, is pi over 2 again. And actually, let me go and calculate the phase shift. Negative C over B, negative 0 over 1. There is no phase shift. And actually, on the last graph, I should have done that here. After I made this sketch, I should have said, and now the phase shift, negative C over B. Oops. Yeah. So there was no phase shift. We'll do some graphs of phase shifts in a few minutes, but for now, so let's do this one. So what do I have now? First, I know my amplitude is going to be 2. So now, on my y-axis, I'm going to go from -2 to 2. My period is 2 pi, so I go out here and I mark my 2 pi, and then I can sort of start marking these other points. And you notice the key points are pi over 2, pi over 2, pi over 2. And now, since I'm doing the cosine, once again, this is the graph of 2 cosine x. Cosine, when I'm at an angle of 0, my cosine actually is at the maximum. In this case, it's at 2. When the angle is pi over 2, my cosine is 0. When the angle is pi, my cosine is at the maximum again. 3 pi over 2, it's 0. And 2 pi, and back up here. Now if I connect these points, and there is my graph of y equals 2 cosine x. Because there's no phase shift, then I'm finished. All right. How about the graph of y equals sine 2x? A is going to be 1. Looks like B is going to be 2, and C is 0. So I know the amplitude is going to be 1. The period is 2 pi over B, which is 2 pi over 2. Actually, the period is now going to be pi. And what I call my key points are going to be now every pi over 4. Phase shift is once again 0 since C is 0. So now, based upon the information I have, let's make a rough sketch of this graph. Amplitude, now we're back to 1. So we'll go from -1 to 1. Now the period, you notice here the period's pi. So I go here and I mark pi out here. And then when I start dividing up my graph, half of that is pi over 2, half of that's pi over 4, and then 3 pi over 4. So I showed you my key points. Every pi over 4 now is a key point. Now, since I'm graphing the sine at an angle of 0, the sine is at a maximum. So I go up here, or no, I spoke wrong, I got confused. The sine is actually at 0. Now here's where the key points come into play, because every key point I'm either at a maximum or 0 or a minimum. So if the sine starts out at 0, I know at the first key point it goes up to a maximum. At the next key point it goes down to 0. At the next key point it goes to the minimum, -1, and then back to 0. So then if I try and draw in so this is the graph of y equals sine of 2x. So you notice the amplitude is 1. Here the difference is the period. The period now has been reduced to pi. All right, let's just do a few more of the kinds of problems you're going to see in the homework. Hopefully you're starting to see how this works, and it's not too difficult. Let's go back and do another cosine. Y equals 1/2 cosine 1/2 x. All right, that looks interesting. So we know that the A is 1/2, my B is 1/2, C continues to be 0. So I know the amplitude is going to be 1/2. The period is 2 pi over 1/2, which is actually 4 pi. And the phase shift is 0 again. So now, as I try and draw my cosine, so first of all, amplitude's 1/2. So now I'm going to mark this, and that's going to be 1/2. And down here is -1/2. The period's 4. Just to make sure my key points, every pi is going to be a key point. So let me go out here and mark my 4 pi for my period, cut it in half, 2 pi. So every point on here is my key point. So now that I'm doing cosine, at an angle of 0, the cosine is at its max, so it's up here. The next key point goes to 0. At 2 pi, it's at a minimum. Back to 0. Back up to the maximum. So there's the graph. Y equals 1/2 cosine 1/2 x. Let me do one more, and then we'll do some phase shifts. So far, none of these have had any phase shifts. So let me do one more that you'll sometimes see in the homework. This one's going to be a little different. Y equals 3 sine of pi x. Once again, pi is just a number. So my A is going to be 3. The B is going to be pi, because the B is whatever's in front of the x. And C is 0. So the amplitude is going to be 3. The period is 2 pi over pi, which means the period is 2. And now the key points is 2 over 4. Key points are going to occur every 1/2. And of course, there's no phase shift. So what would a graph like this look like? The big difference here is, first of all, the amplitude is pretty straightforward. It's 3. So I'll go up here and I'll mark 3 and -3. Now the period is 2. Up until now, all the graphs have had the period as some multiple of pi, either 2 pi or 4 pi. Now it's 2. So I'm going to go out here and I'm just going to call this 2. Now if I do the same thing, if I cut it in half, it's 1. And then here's 1/2. And here's 3/2. Now that sort of makes sense because I'm saying my key point spacing is 1/2. So every 1/2, I'm going to have one of my key points. Now since this is a sine, at the angle 0, the sine is 0. Now it goes up to its maximum at the first key point, back to 0, then down to its minimum, and then back to 0. So this is a rough sketch of this sine wave. So the difference is because B has a pi in it, you can see the x-axis is no longer, the numbers no longer have a pi in them, it's just a number. Now let's do a couple phase shift problems and then we'll be finished with the first part of this graphing trig functions. So now let's do this one. Y equals sine of x plus pi. A is 1, B is 1, now C is pi. So the amplitude is 1, the period is 2 pi over 1, which is 2 pi. The key point spacing is going to be pi over 2, pi over 2, divide that by 4. But now there is a phase shift. Phase shift is negative C over B. So negative pi, and B is 1. So a phase shift of negative pi. Now what I'm going to do is, I'm going to make a graph initially ignoring the phase shift. So I'm going to make a graph where I have amplitude 1, a period of 2 pi, and then I'm going to apply the phase shift. So here's how that'll work. This I find is usually the least confusing way if we're trying to figure out what these graphs look like. So the amplitude, negative 1 to 1, the period is 2 pi, and I'll get my key points now, pi over 2, 3 pi over 2. Now I'm going to make a sketch. Now actually, I'll put my points in here. Since we have a sine wave, we know it starts at 0, and it goes to the maximum, back to 0, minimum, back to 0. But actually, I'm going to instead of drawing a line, I'm going to draw a dashed line, because this is not my final graph. It's just a mid-graph. So I'm going to try, just to make it clear, this is not the final graph, because this does not include the phase shift. The phase shift says now you take this whole graph, and since it's a negative pi, I'm going to move it to the left. Every point's going to get moved a distance of pi. So this is going to be interesting. So here's where it gets a little goofy. Maybe I'll get my red pen out again just so you can see it, hopefully. I'm going to take every point on this graph. You know, this is the distance pi right here. So basically, you know, this first point is going to go from 0. I'm going to move it pi, so it's going to go over here. This point is going to go about right here. This point is going to go here. This point is going to go here. And then this point is going to go here. So now, if I can keep track of these red points, and hopefully you can see, maybe it's sort of clear right here, from here to here. I've taken that whole, this sort of dotted line graph, and I've shifted it to the left by pi. And therefore, this graph right here is y equals sine x plus pi. So with this phase shift, what I do is I normally make a sketch of the graph before I include the phase shift, and then try and just shift the whole graph whichever direction I need to. All right, we'll do one more. This one maybe is the most complicated of all. Let's see if we can figure it out. We want to graph y equals 2 cosine x over 2 minus pi over 2. All right, let's just start out. Even though it looks a little confusing, let's just figure out the A is 2. The B, whatever's in front of the x, actually, we would say there's a 1/2 in front of the x. And the C is negative pi over 2. So we'd say the amplitude is going to be 2. The period, which is 2 pi over B, going to be 4 pi, and my key points are going to be pi. And let's go ahead and calculate the phase shift, which we're going to apply the last thing, negative c over b, negative a negative pi over 2. So I write the negative first, then I go get the c, and I see that the c is negative pi over 2, and all that over 1/2 over b. So the negatives cancel out, and by the time you get rid of this complex fraction, you end up with just pi. So the phase shift is going to be pi, which means I'm going to move pi to the right when I'm all done. So let's do the graph. Let's ignore the phase shift for now and try and draw the graph of this cosine function. Since the amplitude is 2, I'll put a 2 and a negative 2 on my y-axis. Since the period is 4 pi, I go out here and there's 4 pi, and there's 2 pi, and pi, and 3 pi. So let's sketch this cosine without the phase shift. So amplitude's 2, period's 4, it's a cosine. Cosine starts high, and it goes down to 0. At 2 pi, it's at its minimum, back to 0. So if I sort of do a dashed line sketch, since this is not my final graph, so right here is actually the graph of 2 cosine of x over 2. If I wanted to, I'd say that's the graph, y equals 2 cosine of x over 2. But now if I want to include the phase shift is pi. So I need to take every point on this sketch and move it to the right by pi. Now pi is this distance right here. That's how far pi is. So here, we move this point to right here. This point goes to right here. Maybe I'll circle it so I can tell it's there. This point goes right here. This point goes here. I'll circle it again so I can see it. And this point probably goes about right here. So now if I connect all the red points, and hopefully you can see now, if I look like right in here, the red graph, the red line has basically been shifted to the right by pi, and then this red graph is actually the graph 2 cosine x over 2 minus pi over 2. So that's pretty much the best way I've found to try and figure out these trig graphs.